Hi, it's Jamie Austin. We're in the van. We're getting ready. It's going to take us 50 minutes or so to get the vehicle, well, 10 or 15 minutes to get the vehicles in the water, and another 50 minutes or so to get us down to the seafloor. We are going to launch today at what you were on your dive form seeing as waypoint 3. We've made a decision to shorten the dive, but I'll explain this a bit more here in a moment. We're going to be running at the beginning from waypoint 3 towards waypoint 4 and waypoint 5. That's an aggregate distance of about 1 kilometer. We'll be spending time, we'll be moving forward with the ship and with Sirius at about 1/10 of a knot and doing what we have been doing, moving back and forth with the Little Herc ROV. We will be stopping along the way to investigate whatever we find, whether it's outcrops and related biology and or seeps. We did some diving on we did some mapping on this area, multi-beam mapping last night. We have identified a number of seeps, it looks like 5, in the north central and northwest part of this high, mostly west and southwest of waypoint 5 to distances of 600 or 800 meters. What I'm going to propose is that we work our way around counterclockwise from waypoints 3 to 4 to 5, and then work our way over towards those seeps. And we've got 5 identified, and we'll, again, depending on time, identify and work around as many of those as possible. Again, stopping along the way to identify and characterize biology and geology that we see that's of interest. We'll have probably slightly less than 6 hours of time on the seafloor today, but we do have storms in the area. We do have some indication that we are going to have deteriorating weather in the course of the day, and of course the dive duration depends on our ability to safely recover the vehicles. So we'll have to make an assessment on that as we move along. You should be seeing a multi-beam map of the waypoints that I've just discussed and the seep locations on your feed on the website. And now I'll ask for any questions or any input on the dive. Erin Becker is with me, as she has been for the whole leg. I encourage all of the biologists, either listening in on the website or coming in on the event log, to help Erin and me identify biological sites of interest. We will slow down. We will characterize those as completely as we can, given time constraints and given the input we are getting from the beach. So please help us, and we look forward to the interaction.
Hey, Jamie, this is Santiago.
Yes, Santiago, go ahead.
Yeah, I was just wanted to let you know we'll be logging all day too and helping identify. And I wanted to ask you to keep an eye out for places where we see corals. We would like to characterize the corals that we see in this dive pretty well.
Great. So, I mean, the best thing you can do is interact with us on the event log. If you see something, Erin will be sensitized to that. And if you see something, make sure you know, and we will spend as much time as we can to help you do that.
So, are you particularly interested in Paramaricia?
Well, that's one of the targets, I guess, we're looking at, and we're especially interested in the associates, but not only primaries, yeah.
Right. They tend to have lots of associates.
Any coral.
Okay.
Yeah.
Gotcha.
We could take a look at the associates on the corals just to capture the diversity and characterize where they are.
Okay.
Yeah, great, Santiago. We have spent perhaps not quite as much time as we should have earlier this week on doing exactly that, and with your help, we'll slow down a bit and we'll do that en route to the other priorities that we have. ROV nav, yeah, survey 1 is out of the room, so. Yeah, once again, ROV nav, we're moving ahead relatively slowly, and we would like to. ROV nav, watch lead. Yeah, I just want to reiterate that we will be moving ahead slowly, but I do want to do some side to side with Herc, and we'll be ready to stop the ship if we run into interesting features. Thanks.
My hypothesis is that if I were a fish and I eat smaller creatures, then I suppose facing into the current would mean that those creatures would be more likely to get blown right into my mouth.
Well, it's
Just
certainly
speculation.
certainly true of trout in streams. They tend to face in the direction from which food comes.
That makes sense.
So, oh, there you go. We might want to take a zoom on him. We might want to take a zoom on him.
What did you say it was, Dave? Is it a chimera? Or a half-fish? All right, you're right. Chimeras are those ones that, well, there's a long-nosed kind and I guess a non-long-nosed kind. But
Yeah, video, you let me know when you've got...
But Bob guesses half-fish. H-A-F-F-I-S-H. Half-fish.
And lasers are on. I remind everyone that those lasers are 10 centimeters apart. We're trying not to spook the fish, so we're coming onto it tail on. Again, it looks as though most of these fish are facing into the current, and we are as well.
Mike Vecchione says chimera. Oh no! All right.
That was good. That was a good job, though, guys. We got as much of them as we were going to get, I think.
Yeah. Yeah, even that fish is moving backwards there.
Yeah, and the one on the foreground looks like it's actually in a bit of a depression. So it's now is that staining bacterial related? Do you think, Aaron?
It's tough to say.
A lot of small burrows in the foreground here.
Because it's not a clear mat, and you don't see the dark staining around it, so I don't know. Could be.
Pretty good visibility, though. I mean, we do have a current here, everyone. Looks like most of the fish are facing up current, but it does appear that our visibility is quite good. The view from Sirius of Little Herc is excellent.
What? What kind of fish is that? Is that what you ask? I'm not sure. Anyone out there? Eel pout. That one.
It's an eel pout.
Thank you, Mike. Mike Vecchione who works at the Smithsonian and works with NOAA, has been with us to help identify a lot of these fish and midwater species.
They must see the zooms today. No, I don't think so. I think we're fine with that. Thank you.
Okay, so if you took a sample of this sediment, everything living in there would be in fauna, whether it's larger than a millimeter or smaller. And then the myofauna would just be a particular size class. You put everything through a 1 millimeter sieve, and everything that comes through that basically is your myofauna.
Great. Well, thanks for that input, guys. Got some staining here. First, we've seen a bit of any significance. We are, again, this is dive 9 of Okeanos Explorer Leg 3. We're in the northern Gulf of Mexico, south of the mouth of the Mississippi River. We are in a water depth of a little over 1,000 meters, and we are working our way a little bit west of north towards an area of concentration of what we think may be seeps at the seafloor. We are stopping along the way as we go to look at interesting features, either geological, biological, or anything else we may happen to see. We welcome your participation, and we're happy you're here with us. This is the Okeanos Explorer. That looks more like an eel, but we'll be glad to have input on this. Very nice. Very nice. You can see evidence for the current now. That organism is facing up current. He's drifting slowly down current. Well, that's an interesting little, was it amphipod, copepod, something in the foreground there? Interesting.
Bob says a polychaetes. I didn't see it, though.
Wonderful view of an organism floating gently with the current, gently down current, but keeping its head up current. There you go. Santiago has given us an official definition of myofauna. Go ahead, Aaron.
Yes, thank you. It's larger than 0.63 micrometers, or microns. but lower or smaller than 1 millimeter.
Thank you. There was a time when I actually took a biology course at Woods Hole, but it was the fall of 1973, so it's been a while. I'll bet you I heard that. We did see drainage-looking features yesterday associated with that brine feature. That could conceivably be part of what we're seeing here is escape of brine near the top of this dome that we're on.
This is a crangonid shrimp.
Now, is that a commercial variety of shrimp? I have no idea. I mean, that's a 5 centimeter long or longer.
One would think. I'm not sure. I know that those red ones we see are called royal reds. It's their market name. So those are commercial.
So they are
fishery.
harvested commercially.
This one, I don't know, but I mean, seems like they would be, huh?
You might expect to see that near the top of a feature like we're on right now. It's probably the cap of a salt dome. Don't know where the salt is below us, but we saw these yesterday in association with that brine pool that we surveyed.
This site is actually offset from the salt by quite a bit. It's probably in the order of a kilometer or two to the south of us.
But it's a topographic high for a reason.
Yes, and it's constructive. We think it's because sediment. One time it was probably an active mud volcano.
Okay.
It's no longer actively spewing mud from a discrete crater. We've been to active mud volcanoes where you see the brine actually flowing down like a river, and the position of that river can change through time. So you see one, and then on the other side you'll see another, and then they start to coalesce and cross each other.
Right.
And that's very likely what we're seeing here.
Great. Thanks, Bill.
It's no longer actively, flowing brine.
Yeah, I know. I just mean, what is it in Fahrenheit?
Oh, it's low 40s. Nice looking.
Oh, is this guy alive?
I was going to say he's had a hard night. I'm not sure that he's and he's got sediment on top of him. Now there's something underneath him though. There's
a little eel pout.
Is that an eel pout to the right under his legs there? He doesn't look alive, that crab, to me. I mean, he looks. But I mean, that's a classic example. I mean, there's a shelter for another organism to the right of that crab, and that crab is no longer with us, but doesn't mean that he doesn't provide shelter for another organism. Yeah, it's becoming sedimented. And that's a good point to make. In fact, even in a place like the Mississippi River, we're looking at sedimentation rates here that might be, and these would be very rapid rates, millimeters a year of sediment. So that's a very, very rapid rate. We might be looking at 10 millimeters 1,000 years of sediment in the deep ocean. So we're looking at sedimentation rates that are extraordinarily high here, but still slow by most people's standards of fast versus slow. It's a very photogenic organism. Saw one earlier. He didn't stick around long. He was not interested in having a sneak up on him. Pretty flat seafloor here, but we've got a lot of burrows. And once again, he was interested only up to a point. He wants to get out of the field of view. Yeah, again, I think we're seeing a variety of features, some more recent than others, that suggest that there has been flow of dense fluids across the seafloor at some time in the past. We may see that start to become more prominent as we get up towards these areas of suspected seeps, and we're headed there now slowly. We've got about 340 meters to go to the first seep location. Seep location.
A lot of little pits around here and some flow-like features. I mean, clearly some dark staining and some linear features that look like brine flows. Yeah, this fish actually looks like it's sitting in brine, as a matter of fact. You can see it kind of wafting around that fish. Looks like it. Doesn't it look kind of cloudy and insubstantial? It looks alive. I don't know why it would be hanging out in this super salty water, if that's in fact what it is. But see, it looks like the bottom of it's kind of obscured by this shifty liquid. Yeah, Catriona also asked if this eel pout is alive, and I'm not sure. It's not moving, but it's kind of moving. It's hard to tell if it's just wafting around with the brine that it's floating on. You should try to scare this fish and see if it floats away, or swims away. Bob says the eyes certainly look like those of a live fish, and I would agree. I mean, there's nothing about this fish other than that it's sitting in brine that would suggest to me that it's not alive, really. And that's just an assumption that we would make, I suppose, is that that would be a tough place to live. Yeah, certainly alive. You could see him move his mouth there a moment ago. Okay, moving on.
That brine might be a little bit warmer too. Maybe that's like a little hot tub for him.
Could be, could be. There's a magid crab. Spiny. I don't know. Santiago asks, it says the carapace is clean. I noticed that too. Often these crabs have a lot of barnacles on them, particularly stocked barnacles. And so Santiago asks perhaps if it recently molted or something.
I definitely molt when I have
Possibility.
barnacles on me.
Right. Tired of carrying around these barnacles.
We're also in an area of the seafloor that's quite interesting. When we get through with this zoom, we can pan around a bit. You know, again, more of these features that look like drainage features that might have been old pathways for supersaturated fluids.
Yeah, so we have these drainage features, and there's also a lot of these little dark spots that just look like holes, you know.
Well, they would have been feeders. If fluids are leaking up from below, they would have been feeders for those fluids.
Right.
It's not really like a river, although rivers are also fed from the sides. These might be fed by circular depressions within the feature itself. And I think we're seeing some of those, although we're not seeing the fluid.
They're just a bit different than what we saw yesterday, where we had kind of larger round ones, and these look like smaller.
Yeah, you know, but you've got a very, what we call a braided pattern of channels, and that could be being fed by many, many feeders underneath. This could have been an old brine pool where the brine stopped leaking out and the brine pool slowly mixed with seawater and disappeared.
We actually saw a little tiny brine pool with a fish in it. It was just hanging out in there.
Yeah, I mean, so you might be seeing, you know, whether a brine pool maintains itself or not, it depends on how much brine is leaking from below. So this looks like an area like that. We are about 50 or so meters from our first, in quote, seep location, but I reiterate that these seep locations, as we have mapped them, have a certain amount of error associated with them. In 1,000 meters of water, that could be somewhere between 50 and 25 meters of horizontal distance. So the fact that we're 50 meters south of our designated, southeast of our designated target suggests that we are already in an area of interest from a seep point of view, and it certainly looks like that here. A lot of these pock marks, some of these could be related to burrowing, and undoubtedly are, and some may be related to escape of these fluids that create these drainage-looking features in front of us. Fascinating, fascinating-looking seafloor. Now, once these brines emerge at the seafloor, they are also motivated by the primary force that motivates rivers, which is gravity. So those brines will begin to migrate downhill. So we might be looking upriver right now at one of those features. Brine might have been migrating down at us from slightly above. The gradients here are quite low, obviously. We're not looking at very big dips. But the brines will fill up pools and then migrate down with gravity. Yeah, it's a great shot now, migrating up one of these features. And when I say up, I'm assuming it's up. I'm not sure. We would have to be looking.
Looks like up.
Looks up, but we would have to double check that. where you get highly braided patterns, what we call anastomosing patterns. When the channels come apart and come together, it looks a little bit like a braided rope or a braid in your hair. It's a little harder sometimes to tell by looking down on these features where is up current and where down current is, particularly on a part of the seafloor where you don't have much in the way of dip. Yeah, there you go.
Oh, those weird little holes.
Yeah, yeah.
I've never seen ones quite like that. It's
well, and I
different.
don't know that they're all biological. I mean, they may be
No,
old
they
fluid
look all-
escape
It
features,
could
and
be.
you know, there's where some tributaries came together. Yeah, it's great.
Oh, so there's a little fish in the brine pool there.
Yep. You know, and that could be, remember, these brines will slowly re-equilibrate with seawater and slowly disappear if they're not fed from below. So you think of a puddle that's slowly drying out in the sun. You know, these pools are the same way. If you don't get replenishment of the brine from below, the brines fill depressions and slowly will mix with seawater and disappear. Where they're being fed, no. Now there may be a little brine in that depression right there, where you get a kind of a cloudy look to the seawater. That could be a little bit of brine left in the depression. Same with the low up in front of us. Fascinating seafloor here. Somewhat similar to what we saw yesterday, except yesterday we saw in the Ewing 915959 area, we saw an active brine pool, a brine that was being fed from the subsurface. Santiago asks whether yesterday's brine could have been recently formed. Well, we did see that in that brine channel. We saw organisms, the anemones in particular, staked out along the brine. Now, they weren't in the brine. They were above it.
I think he's talking about the pool that we saw earlier.
Yeah, I'm not that familiar with looking at fauna living in brine. I have heard that there are some organisms that can coexist in those supersaturated environments, but I'm a little bit pleading inexperience there. I wouldn't know how to gauge the age of a brine, but here we're not seeing brine. We're seeing evidence that brine has been here and flowed through here. That's more a function of the rate of input from below than overall age. But anybody out there that wants to chime in and help us here, that would be great.
Certainly thinking more and more that these little pockmark features are geology, well, gas escape basically.
Certainly, Bob, Bob Carney's talking about remnants of a complex mud flow. Bill Shedd has mentioned that this is in part a topographic high related to a mud volcano, and you do see on volcanoes of mud, and these can be warm muds, cold muds, but muds mixed with supersaturated fluids, generally water, but it can be water plus hydrocarbons. They often do form braided stream patterns like this. We aren't seeing evidence for active flow right now, but we may as we move up towards our seep area to the north.
Back to Santiago's question. He asked about fauna on the periphery, so not necessarily in the brine. And sometimes you get lots of fauna around the periphery. Sometimes we see there are these particular kind of urchins that burrow around in those reduced sediments, or sometimes you have mussels that live around there. But I've seen a number of brine pools without fauna. I don't know if that means that they're newly formed, but there can also be, the answer is that there can be a number of reasons why animals are not there, that are not necessarily that they haven't gotten there yet. Or it could be that they don't like it, or it could be that they haven't gotten there yet. It's not really sure.
And remember, it's not just supersaturated water that's coming up. There can be dissolved chemicals with this. There can be gas. There can be oil. There can be toxic chemicals as well. So it may be a function of toxicity of the fluid. I don't know, but
could be, or it could be that there's not enough of what the mussels would need.
Yeah, this view right here almost looks like there's desiccation cracks, or obviously they're not drying out at the bottom of the ocean, but you might be seeing some minerals that are causing the mud to kind of shrink and crack into that pattern.
Yeah, I absolutely agree that you are seeing evidence for precipitation along the bases of these drainages. And,
Yes,
you know,
yes.
desiccation is not the process, but it's certainly plating
No,
with
no.
chemicals. And we are seeing that.
Right.
There's no question that we are. And it helps you actually differentiate the drainage. If you look up now in the far field, you can look at river systems on land and see a braided pattern very much like that. And it's related to intermittent flow, low velocity flow across regions of low dip. And you're seeing something very similar, but you're on the seafloor. It's fascinating.
Yeah, I was gonna say I've seen this kind of pattern on the beach. Sometimes you see it in
Absolutely. See it
the
across
sand.
beaches. You can see it where there is spring sapping at the bases of cliffs, and then you see them come across beaches at very low velocities, at very low dips. Very similar phenomenon.
Yeah, well, we see channel systems in the Gulf of Mexico that are meandering the same way rivers meander on land.
That's
Deep sea turbidites can do the same thing.
that's exactly right. And it's related to density differences between the seawater and the material that's flowing in one of these streams. ROV Nav, we still have a ship stop? Yeah, we can begin to move slowly towards C4 at a tenth is fine. Can't tell whether that's an organism or
I think
debris.
it looks like an organism. An anemone, maybe? I can't tell if it's actually stuck on the bottom. No, I think it's not. It's not.
And that's
Jelly?
That's an interesting shot too, because it shows you that it shows you a level there that might be the level, the darker level might be the top level that was reached by the supersaturated fluid along the flanks. Wow, that's interesting. What is that? Bob Carney makes the comment that not all brines have sulfate, only some can support sulfide generation. That's certainly true.
Right.
Very diverse chemistry associated with these brines, and it depends on where the brine has been. It refers to the plumbing system that I talked to earlier. They can be coming up from a great distance below the seafloor, and they're picking up chemistry as they go, and their underlying commonality is that they're all dense. But that density can be quite diverse chemically. Quite a lot of fish in this vicinity. We're seeing. I guess it's chimera. It's not chimera. It's chimera with a hard ch. Rat tails. In and out of these discolored, the darker colors, I think are pretty good indicators here of the bases of these channels. The topography is quite gentle. The up and down is quite gentle, but I think we're looking at evidence. Cyrano de Bergerac fish. And again, other evidence for paleo drainage, old drainage here. Getting very, very close now to a ship stop so that we can inspect the area around our first designated seep location. I'm not seeing, don't see schools of fish down here. You see individuals, but you don't see schools. I mean, is schooling behavior a surface water phenomenon for fish?
That's a good question. I don't know.
Fair enough. Thanks, Bob. ROV Nav, we have a ship stop now. Roger that. Looks like we have another crab in the right rear field. Take a closer look at that if we could. That one looks a little more alive than one of the ones we saw earlier. Although it looks like the same type of crab that we saw that had.
Yeah, chasey on this one.
He's perceiving the ROV and is getting a little energized by our presence here.
So you can see this guy has some barnacles on him. So the other one that was completely clean, didn't have any mud on it, didn't have any barnacles, that does seem to indicate that it had recently molted, shed its whole exoskeleton.
Now, when you say the whole exoskeleton, does that include legs and things, or is that just
Yep.
the carapace? That's the whole thing?
Yep.
Wow. I guess that's right. I mean, soft-shell crabs. You know, you go eat a soft-shell crab, you're eating the entire crab is soft. It's not just the carapace. Oh, whoa, whoa. Well, there you go. Well, it's a crabby crab.
Aaron, what is that clump off on the left-hand side of the screen?
Yeah, ROV Nav, can we get a zoom on the clump of debris in the foreground as well, please?
So that's sargassum. It's a kind of seaweed that we see floating around in rafts on the surface of the sea, and then occasionally it sinks.
Certainly is associated with complex ecosystems on the surface, but perhaps not here. We'll get a zoom on it. We'll give everybody a close look. We have seen an extraordinary amount of sargassum at the surface in the last few days, quite a lot. I don't know whether that's a spring bloom or what, but more than I ever remember seeing in the Gulf of Mexico before. Yeah, maybe. And I guess that what keeps sargassum floating are these small air bladders, and then at some point they wear out, the weed dies, and it sinks. That's great. And can we get the lasers? That'd be good. There we go. 10 centimeters. That's, we've seen clumps of varying size, but that's a pretty typical sized clump. I don't know what the technical term is for sargassum, but that's a clump.
Right.
Seaweed to me has always come in clumps. I first perceived seaweed as something you gathered in handfuls for clam bakes. We're just about at a ship stop now, and we're in our first designated seep area, and we will do what we have done in the past. Obvious if we can get a good look at it. Certainly seems to be what we thought it was. Seems to be a coconut. It's got a little moat around it, though. It's actually been on the seafloor for a little while because the current has shaped a little moat around it. So it didn't just show up there. It's been there a while. It's got a little sediment on top.
Polychaete?
It's got a little sediment on top of it. So that coconut's been there a bit.
Scale worm, I think, on the bottom there.
And that little excavation around it is a pretty good indication that it has been an object in contact with the ambient current for a while. Is that a shrimp there covered with sediment on the left?
Oh, I don't know.
Looks like a.
It does have the shape.
We can take a zoom on that object on the left. That looks remarkably like a shrimp, but it looks completely covered with sediment.
Yep, definitely a little scale worm there. Jamie wanted to quickly check out what that object on the left is. And then if we really want to determine whether this is a pina colada container, I think we'd have to look at the other side. I think that's where it would be cut open. I don't know, still hard to tell what that is. Yeah, maybe a stick with some stuff on it. Yep, bit of wood with some mucus. Okay. Cool. And then if we could just look at the other side of this coconut, I just want to, we don't have to zoom in on it carefully necessarily. I just want to look at it. Right? Coming up on some kind of hole in the seafloor. Looks like a burrow. Especially since there's one side of it that's dug out a bit more. There's another chimera fish. It's a long nose kind. And that long nose is probably sensory, used for sensory purposes. Since these fish live really deep, there's no light, so they can't really rely on their eyes so much to find prey and so forth.
Yeah, pretty good view now up one of these meandering depressions in the seafloor. It's not very big, but enough to hold what I believe are probably supersaturated brines. When those brines are extruded at the seafloor, there's not much evidence for that at the moment, but that's what that feature has to be. Certainly not much biology associated with this particular feature. We have seen biology associated with them. We did yesterday, and we may. Yeah. As we get up to the seep area, we can do a good look around. Well, I think it's their paleo fluid flow, their discoloration associated with the base of these channels may be related to chemistry of the brines that flowed through them, changing the color of the sediment. reducing potential of those fluids. We've often seen this darker color at the base of these channels. Helps you identify them on the seafloor. I think it's too small. You get a ground cable, it would be a really big scar. Seismic cable. Well, there are two ways to collect seismic information in the Gulf. Well, there's more than two ways, but the two main ways are to actually tow a hydrophone array behind the ship and to shoot to it with a sound source of some kind. Generally, they're pneumatic compressed air sources. Or you can actually put cables on the seafloor, and that saves you of having to tow them around in space. Of course, you don't get the amount of spatial coverage that you get. But if you want, then you have the advantage of shooting multiple times to a receiver in one location. So you can actually build up a lot of information about one place in the subsurface. And they will do that in places near a prospect, for example, where they might want to drill a well, or where they want to understand the dynamics of the reservoir they're going to sample. These reservoirs, you can actually see the fluid migrate through these reservoirs over time. And so they might want to get time-dependent measurements, acoustic measurements, and then they can put a cable down or many cables down and get three-dimensional information. It's a lot of work to do it, but they can do it. I don't know whether they're doing it in these water depths routinely. I don't think so. I think they're mostly using towed streamers out here. Call them streamers. Hydrophone array, streamers, various cables, eels. They're various terms describing the same general piece of equipment.
Yeah, they are shooting 4D data is what it's called.
Right.
They'll
Yeah.
leave cables down over time and watch the reservoirs deplete, or in some cases they'll do gas injection.
Yep.
And watch the progress.
Yeah,
they do it in this water depth.
Yeah,
yes.
Bill Shedd at the Bureau of Ocean Energy Management is confirming that. I mean, it's called 4D as opposed to 3D. 3D refers to spatial sampling, and 4D refers to spatial sampling over time. And they are using ground cables apparently in these water depths here. And I'm not going to swear that we're not looking at a ground cable mark here.
Probably not, because we don't have a platform nearby.
Right.
You typically will see that near platforms. They also have put nodes down with individual phones, geophones essentially, and they'll set those down in an array and leave them, and they'll transmit the information back to a ship.
Roger that. Yeah.
So they'll leave those there for years.
Yeah, so there are various ways of acquiring acoustic data in the vicinity of either exploration or producing wells, and ground cabling is one. They can put individual acoustic sensors down, nodes, and actually transmit for a long time, because understanding reservoir dynamics, actually what the fluid holding part of the geology is doing, either depleting or regenerating with time, or if they're injecting fluids to drive production, is an important part of the process these days. And the imaging has gotten, acoustic imaging has gotten so good that they can actually look at the fluid regime within the reservoir that they're sampling for oil and gas. It's expensive though, folks. This kind of measuring is expensive. So it's a little bit like ROV work. It requires people with experience. It often requires pretty big ships with pretty big compressors. And these days in the Gulf of Mexico, there are a lot of people wanting it. So you've got to actually organize and schedule these tools so that they're not interfering with each other acoustically when they're out collecting data. ROV nav, we're moving northwest from here. Is that right? Yeah, yeah, we might do a ship move when we're done here. Oh, let's go 20 meters east or 20 meters southeast and look a little more to the southeast. We're going up here and then down to 2 or 1. We're going up and then. A lot of subtle shading differences in the seafloor, some of which are related to these small channels. And as you pull wide, you can see the intricacy of these channel systems. I think before the end of this dive, we're going to see some evidence for brine escape, but we haven't yet. Yeah, I just want to convince myself I'm seeing a little bit more of these drainage features before we move northwest. Still doing a search around our third seep area, but we're moving a little bit south and east of that area now. We're seeing some evidence for channeling. Looking for outcrops. Haven't seen much in the way of outcrops on this dive so far. Been pretty soft seafloor. In fact, it's about the least, in terms of sessile attached biology, it's about the least populated stretch of seafloor we've seen so far this week. Seen a fair number of fish, but not much, and some crabs, but not much in the way of attached biology. And that may be because there simply are no hard, there's no hard substrate to attach to at the seafloor here. Nice view, a longitudinal view of one of these features that I think are all braided and anastomosing subtle drainage features. Fascinating seafloor, you don't see that very often. You know, I could probably Google that for you. I think they're looking at water depths now on the order of 2,500 meters for water depth completion, and below 18,000 feet, 6 kilometers for what they call TD, total depth below the seafloor. And that's, well, I'm sorry. This is, I just got a question from one of our video engineers about the water depths in which oil companies are working these days to drill oil wells and or production wells, and then the water depths they're working in. It's my understanding that the water depths now are around 8,000 feet, about 2,500 meters, and that the depths, the target depths, are on the order of 18,000 feet. Around 5 to 6 kilometers of total sub-seafloor penetration. And a well like that could easily cost on the order of, you know, it's costing tens of millions of dollars. I'm not exactly sure, but probably somewhere between $30 and $50 million to complete a well like that. And that doesn't mean putting then the production equipment in place, assuming you find hydrocarbons to produce hydrocarbons from it.
This is Bill Shedd with BOEM. The deepest well drilled in the it was a dry hole, but the deepest well drilled was about 10,500 feet.
10,500, okay.
Yeah. The deepest production is close to 9,000 feet. I think it's around 8,600 feet or so.
Great. And water depth, Bill?
No, that's the water depth.
Ah, water depth, sorry.
That's water depth. Yeah, yeah. And they're drilling, a lot of these wells are completions at 18,000 feet or so below mudline.
Right. Okay. So Bill Shedd is. Go ahead.
Yeah, and the deepest production in the Gulf is actually up on the shelf, was about 32,000 feet below mudline. It was in about 400 feet of water.
Wow. Okay.
So,
Bill Shedd from the Bureau of Ocean Energy Management. Apparently, they're exploring now in water depths of 9 to 10,000 feet, producing from depths of around 18,000 feet, as I said. But they're getting production up on the shelf from sub-mudline depths of about 32,000 feet. That's about 10 kilometers. That's quite something. And the cost of something like that, Bill?
It's about $400,000 to $500,000 a day, and they can take anywhere from 30 to 90 days to drill.
Okay, so let's see, a rig like that costs $500,000 a day, up to 90 days. So I wasn't too far off. Could cost you something on the order of $40 or $45 million to drill a well like that.
Right, and then complete it. That's going to be close to double.
Right, and then to make it a production well from a discovery well would be double that.
The platforms run $3 to $5 billion.
Right, production platforms, a little bit like the Deepwater Horizon, the Macondo platform. That was over $1 billion, but apparently some of them now are over $3 billion to put in place. And they may be in place for years because they're producing not just from one location, from many locations.
Yeah, and they'll drill a number of smaller fields and then tie in with subsea lines to a central location.
Right. So these are harvesting multiple discovery wells in one location. I don't think we've seen any of the super big ones out here. We have seen producing wells. There's some of the rigs around Okeanos, but none of the really big ones.
Probably not on this trip.
Right.
Not on this trip yet.
That's great, gentlemen. So
some of these,
if you're comfortable that you've done a little bit, done pretty good coverage on the move to the southeast, I think we can prepare to go to SEEP. Is it 5? Roger that. 1/10 of a knot. Thank you, Bill, for that help. Needless to say, $100 a barrel hydrocarbons helps the exploration effort. We may complain at the gas pumps, but $100 a barrel oil, when we start getting into deep water production, it starts being an expensive proposition to produce the hydrocarbons we all get used to using every day.
It's Bill again. Keep in mind that it's the lease rig. They'll lease it for, like the Deepwater Horizon's leased by BP to drill several projects over a period of time. And whether they're drilling or not costs them about $400,000 to $500,000 a day.
Right, Roger that. Yeah, Bill emphasizes that whether you're actually using this equipment or not during a lease, it can be costing the same rate. So it's worth your while. But this is one of the reasons that companies are very sensitive to changes in regulations, because they can be leasing this equipment, and then if for some reason they can't use it, they're still paying for the equipment. Okeanos Explorer is not free either when it's at the dock. Even when some of you are not on it, it's still costing to maintain and keep in readiness to be used. Now, is that a crab out there? I guess
Yep,
so.
that's a crab.
That's a crab out there.
Like the magid kind.
Puff the magic crab.
Lots of fish around here. That one is a halosaur.
Erin's about to regale us with all of the research that she's been doing on Google with these various fish. And so we're going to introduce her now. Erin Becker is my biological cohort here in crime. And she's been doing a lot of Google research, and she can now regale us with all of the information that we've been yearning for on these various fish we've been seeing.
Yeah, although we're looking for, our targets are based on areas where we think there's hydrocarbon seepage, and we expect to see some seep-related animals around. But it seems to be what's going on here at this site so far is fish, lots of fish. That one right there in front of us is called a halosaur, which is kind of an eel-shaped fish. And the name comes from Greek halos, meaning sea, and saurus, meaning lizard, kind of like dinosaur, lizard. Tyrannosaurus is terrible lizard. Is that right?
Right. That's right.
And this fish, an interesting thing about it is that it can regenerate its tail if it's lost, kind of like some lizards can do that. A defense mechanism. They just lose the tail and then they can grow it back. And these guys are thought to mainly prey on benthic invertebrates like polychaete worms and echinoderms, that's sea stars and urchins and things, and crustaceans like copepods, which are really small swimming sort of planktonic animals, little crustaceans, which might explain why a lot of these fish are facing the current. They seem to be all facing the same direction when we're passing them, so maybe that's so that they can catch little swimming copepods as they get blown by the current.
That's a good view of that spider crab moving along. It's fantastic. Look at that. Looks a lot like the Martian robots in War of the Worlds. And I'm sure that's where Steven Spielberg got the idea from, looking at those spider crabs. Whoa. It's almost impossible that that thing could move along the way it does, but it's clearly feeling the current and the disturbance of the ROV and has decided that times are better somewhere else. It's fantastic. Now that crab would be a detritus feeder. That would be an opportunistic feeder on whatever organic matter happened to living or dead on the seafloor.
Yeah, I think for sure that they're scavengers. They might also prey upon some living things. Sometimes we see crabs with that actually catch fish in their pinchers. It's surprising. You can never imagine. I never imagined that that's possible. Like, how on earth would a fish happen to swim right into it? But
it's a dumb fish. Dumb fish.
Yeah.
We are now headed from our third seep location, in quote seep location, to our fourth one, which is north and west of our current position, about 140 meters, 140 or so meters. Then we'll swing back down to the southeast. We've been doing a census of acoustically defined seep locations. We have not as yet found any evidence for escaping fluids, but we have seen abundant evidence for channeling associated with what we think are brine escape on the top of this feature. And then we'll head for a couple of waypoints that were designated prior to this dive along the southeastern flank of this high. It's now about 1:15 local time. We should be on the seafloor, I would wager, another 2.5 to 3 hours on this dive, weather permitting, of course. Weather seems to have moderated a bit. Well, we don't have much sea state out there right now.
It's a rat-tail fish swimming in front of us. Those are certainly the most abundant ones that we see here. And indeed, they're the most abundant family of fish in general in the deep sea. They can be at great depths in the Arctic to the Antarctic, all over the world.
And we saw them in the Mediterranean.
Yep. Most of these deep sea fish, because they are in a really, a dark, light-free environment, they have extra developed sensory organs other than their eyes, So fish in shallow and deep water have lateral lines for sensing vibrations in the water, but in these deep sea fish, it's even further developed, and they also have a lot of chemoreceptors. So basically, they can detect chemicals in the water, kind of like smelling stuff in the water.
We are now on our way to our next location. Seafloor continues relatively featureless. We do see these channels crossing our paths periodically, not right here. Evidence for pretty pervasive burrowing in the seafloor and fish. The occasional crab, but not much in the way of encrusting biology on this dive thus far. Again, looks a little bit like what might have been the floor of a brine pool. We might want to zoom in on that yellowish patch in that foreground area there. Very extensive. If we have time, yeah, I'd like to take a quick look. Yeah. Yep. Sorry about that. Yeah, that spot right in front of us there. Yeah, that looks like. Aaron, what do you think about this? It looks like debris on the seafloor. Yeah, I mean we're zoomed in on a very small patch of burrows, maybe exhumed burrows.
Yeah, it's hard to tell. It could be burrows. It could be.
It could be debris. It could be an
I was
old
gonna
piece of
say, yeah, it
sargassum
could
or something.
be degraded sargassum.
Right, exactly. Okay, whenever you're ready, you can come back out. Yeah, and we'll take a look at this. This looks like something that could be have been the bottom of some kind of a brine pool area. Yeah, some small topography here. Again, where we see discoloration, I think it accentuates the bases of these channels. Where we don't, it's very, very tough to see. Very subtle differences in relief, but I think it's another one of those channels. Yep, it's almost invisible. Exactly. Sometimes it's a little easier to see looking down on Little Herc from Sirius than it is from Little Herc itself. Yeah, there you go. Another one of those, very small but persistent laterally features. That one's actually whiter on the bottom than the surrounding sediment. Yeah, Katrina, it looks like these fish have been nose upstream for most of the day today. Seems as though the current's been primarily from northeast to southwest, and we're proceeding northwest right now. So if they do appear to be facing up current, we've speculated that may be related to having food come to them. I certainly don't know that, but a lot of them have been doing that.
Yeah, really often when we look at these crabs, they just seem to be piling a bunch of mud in their mouth, and then they use their mouth parts to presumably sift it all out, take out all the little organisms that they want to eat from the mud and spit all the mud out. Really pretty cool how many little appendages they have there. They all look like little arms. He's marching right towards us. Look at all those little barnacles on the spines there too. It's hard to keep that tight focus with the crab marching right for us. It's very interesting, as homogeneous as this seafloor looks. I mean, it looks qualitatively really similar to seafloor kilometers from here, but clearly it's not the same to these animals, because here we're seeing lots of fish compared to other places, and some crabs, and we're not seeing any echinoderms, so any urchins or sea cucumbers or sea stars around here.
Send that up on. Yep. Which one's that? Planning left. I gotta go switch in the back, but I can do it.
A little cloudy here, huh? That's a bummer. Right, so you can just more or less go in a straight line towards the target. Will do. Right. Well, yeah, we are seeing mostly, rat tails and halosaurs. Mike is seeing occasional cutthroats, but hasn't seen any in a while. Cutthroat eels that look kind of like halosaurs until you get close enough to actually identify them. And then we were seeing some chimeras earlier, which were, they were kind of cool. Oh yeah, that's right. We weren't seeing so many eel pouts now either. We were seeing lots of those before. Okay, so I think that this is just a halosaur, but at least he's floating there nicely in the water.
Can we get lasers, guys?
think that the purpose of this actually is... Yeah, they're kind of far away, but I think the purpose of this really is for the video, to get nice video.
Well, that's one of the reasons we're out here, is to get some nice shots of the ambient sea life. That halosaurus being remarkably, well, he was being remarkably, I spoke too soon. That was pretty good shot though.
Jerk. There's a couple of them here. These are Chaseon crabs, also known as golden crabs. Golden crabs.
Let's get the lasers on this fellow, please. There they are. So he's a pretty good, he's got to be 15 or 20 centimeters across. That's a pretty good sized crustacean, as crustaceans go. More than 20, I'd say, 20 to 25. Excellent full face view. He's got some barnacles.
Some mud on top of him.
It looks like he's got a Fu Manchu beard. Could be. Actually, looks a lot like the Pope. In a feisty way, in a kind of an offbeat kind of way. I'm not saying the Pope has barnacles on him or anything like that, but they don't call him Barnacle Pope for nothing.
Yeah. Why do they clean his eyes off? So you can see the barnacles, they have their cirri sticking out. So barnacles are kind of a crustacean, almost like a little shrimp, and they sort of glue their head onto a surface, and then that's their feet appendages sticking out there. So they use those to capture food and then kick them inside to their mouth.
That's great. That's great. And they get a free ride.
Yeah.
Oh, there's definitely a family resemblance there between this organism and the Pope. No question. No question.
By the Pope, we mean...
a Pope. The local Pope. Not the Pope.
The Pope of this ship.
The local
this
Pope.
expedition.
The Pope. The maestro of the ROV team.
That is interesting, how you have a barnacle right on his eye. It's just...
Well, but how do you avoid that? I mean, how do you avoid having a barnacle get on your eye? You know, what does one do?
I mean, I would think that this guy can reach his eyes, but unlike the back of his carapace, I don't. But who knows?
I was going to say, how does one know whether or not that isn't a good thing? I mean, he might.
Right. Maybe they don't see very well anyway, so no big deal if you have a barnacle on your eye.
Very nice. Thank you, Golden Crab.
And of course, they shed all of these barnacles every time they molt, periodically. So.
It's his version of cataracts, according to the owner. Well, that could be. That's. Very nice. Very nice work, gentlemen.
Is that eel pout? Is that a little shrimp?
That's the idea. But I think, let's keep going at 0.2, and then as we get over towards waypoint 5, I'm probably going to have a slow down to 1.1. Yeah, there you go. Another nice set of drainage features. Yeah, now we've got, we're back in seafloor that's really quite corrugated looking. A lot of small, this could have been completely covered with brine at one point, brine moving across the top of this feature.
Yeah, earlier in the dive we were even seeing some orange staining, which could have been bacterial.
Yep, well, it's what we were calling Begiamona yesterday, right?
Bigiatoa.
Begiatoa, the bee.
Yes.
Yeah, see, look at this. This is
Yeah.
definitely fluid-related escape. Getting a little more ship motion now.
Yes, because we're making a turn.
I'm not so sure. I think it's because it's getting rougher.
Because we're actually, getting some more weather here. So we've finished looking at all of our targets that were based on backscatter from last night's multi-beam data with no real event. And now we're moving on to our next geophysical target.
It is testimony to the fact that although you can see anomalies in the seafloor on various acoustic systems, that doesn't necessarily translate into significant seafloor features, and helps us understand what we can and can't deduce from our acoustic systems. A lot of small channels now, though. Very interesting seafloor.
Yeah.
I don't think
Yeah,
much.
because that last one we saw was fatter, bigger and fatter, that other cutthroat eel.
I don't
know
think
if they all
I
are.
don't think the relief on the seafloor is related to biology at all. I think it's all related to geologic processes, fluid movement across the surface at various times.
Right. And I wonder how much of this is just the currents in the ocean, like the bottom currents. Do you think?
I get there's always that possibility, but I haven't. You are on a relatively flat top feature of a high, so that's a possibility as well.
Yeah, I mean, I certainly agree that those ones that you see somewhat wide channels that are anastomosing, it does kind of look like, brine.
Well, and if we hadn't seen brine actually flowing in
and
one of
we
them
already saw it,
yesterday,
yeah.
I would have less confidence. But
And we saw brine today too, a little bit.
exactly. So, but there's certainly true that ocean currents can create features like this on the seafloor too, especially up on top of flat topped highs like this.
Some more sargassum, some seaweed on the seafloor there.
So everyone, that gives us just about an hour left on the seafloor. Hopefully we will be able to get over to waypoint 5 and make our way down to our last waypoint of the day, waypoint 4. May not get there completely, but we will get a good way there before we're done for the day. Another channel-looking feature off to the right on Little Herc right now.
Right, these are kind of deep channels, and it looks, my perception is that we're looking downhill right now.
Yeah, it's
but I'm not really sure.
it's deceiving.
It can be deceiving.
It would be
definitely.
deceiving. I'm not sure.
That's why we were talking yesterday about how 3D video is going to be the way to go, because it's a little tough to get some depth perception when you're looking at a two-dimensional screen. It tends to flatten things.
But you do, in braided streams, you do tend to get convergence downstream. So if we could see this whole area and see some convergence, we would probably be looking in the downstream direction. But boy, really corrugated looking seafloor. I don't think that this is current. I think this is density flow across the.
I agree.
Across the.
Certainly this big deep channel here.
Yep. Very interesting features. Everyone, we have a building swell here, and we are planning now on coming off the seafloor at 3 p.m. Central Daylight Time. That's in a little less than 14 minutes from now. We have covered a fair bit of ground today. We have seen some biology, no outcrops, no encrusting biology, but we've seen some fair number of fish and a fair bit of evidence, inferential evidence for brine escape at the seafloor. So we want to get our vehicles. We're still in about 1,000 meters of water, so we want to get our vehicles up on deck. We do envision that the weather is going to deteriorate here. So very nice. Weather's going to deteriorate. So we're going to have it keep moving towards our next waypoint until we have to come off. So this is nice. Might want to pan left and right here, gentlemen, if we have time. Just look at the smaller features.
Look at this. We're finally getting something. So different colors on the seafloor.
Yeah, that looks remarkably like that brine channel we saw yesterday. Don't see any brine, but it looks a lot like that brine channel. Of course, it doesn't help there, but we are seeing a feature that looks a lot like the features we saw yesterday. was good. You guys are testing my ability to be imaginative. Here, there we go.
Some thicker white staining, which is most likely bacterial mat, sulfide oxidizing bacteria.
And there's Beggiatoa, maybe.
Beggiatoa
with
is
a B.
Name of the sulfide oxidizing bacteria. You can see mats of it that are, well, basically they're in sediments that have sulfide in them, and they can be white like this, sometimes grayish, and sometimes yellow, and sometimes orange. And as far as I know, no one knows why there's different pigments of them. It's the last word I've heard on it.
Seeing the kind of staining now, and as Aaron just said, bacterial accumulations on the seafloor that we saw associated with our brine pool yesterday at Dive 08. And I believe we might be looking at a brine pool here. Yeah.
Of course. We had about 10 minutes to look at the most interesting stuff.
And that is a brine pool directly in front of us. Yeah, this will be Dive 09 Marker 1.
Yeah, we'll have to look at it more closely video, but it does kind of look like a brine pool, just because you don't see the seafloor very well.
Yeah, I see no reason why not. I don't think there's any reason to transit from here. Let's stop the ship. And the easiest way to determine if there's brine in that pool is to get out on top of it and use the thrusters to disturb it.
You probably don't even have to disturb it that much, because actually you'll mix it all up, I guess, if you really...
Well, these fluids are not as easy to disturb as you might imagine. They're pretty dense. But there's a great indication, folks, of what we've been looking at all day, and the fact that they are related to brine, because I'm pretty sure that's a brine pool to our left. And we're stopping the ship now so that we can get a closer look at that. You know, I think we can look at the margin. We can zoom right in on the margin. That will help us. Anywhere on the margin, you can do it. Yeah, and another, yeah.
Oh, it does look kind of solid. I have to try to disturb it.
Yeah, and the next thing, once we get through with our zoom here, maybe we put the lasers on. There is a little relief. It's a little higher to the left than the right, or the right than the left. Then I think what we want to do is pan left and go out across what we think is the pool and try to disturb the surface of it with one of our thrusters. If there's liquid there, we'll do that.
Huh? Interesting.
Yeah, maybe not. You know, if I
That's
guess
sediment.
it doesn't look like if there is fluid there, it's a very small amount. But I will say, given the margin that we see, that fluid's been there in the immediate past. That's
Yeah.
so
Maybe we
that's
should
good.
follow that thing.
That's good. We could follow it along, follow along the shore to the degree that we can, shore so to speak. And
Sure. Now looking a bit more just like a channel there.
well, that's a shoreline. Uh, and one's the right is a little higher than the left. The left has been under. It's a little encrusted. It's been under a dense, supersaturated fluid until very
Certainly looks
recently.
different. Yeah.
And see where some of the recharge zones are. Those are those circular features. That's probably where this pool got. Remember those little volcanoes yesterday? We could zoom in on one of these. That would be good. That little volcano in the upper center. That may have a little fluid left in it. Yeah, I'd like to get a really tight zoom there if we can. That's probably a recharge pipe, a recharge tube from somewhere deeper in the section. That may have fluid in the center of it. And perhaps not.
Yeah, it doesn't look like it, but see around there, it doesn't. Around the edge.
This looks like
See, it looks,
encrusted. Yeah, it looks like precipitated
yeah,
material. It could
right?
be salt. Well, it could be salt. See, I mean,
Right.
it could be as the brine began to decay and mix with seawater, you had some salt crust left over, and I think you've got some salt crust there. And salt here doesn't necessarily mean sodium chloride. It can mean a complex salt that is less soluble in seawater. So it can be a very complicated salt mixed with other things. But that's what that is. You're looking at a spring. What is it? On land? You'd call it a spring of or in Yellowstone. This would be siliceous center. This would be silica. It's not silica here. It's salt of some kind. But great, guys. That's excellent. And I think we can continue to move along, just following the edge of this feature and seeing what we see for the duration of the dive. We've got about 5 minutes left. Or we can just plow it under. We can excavate. Yeah, I think this is another one of those features that probably fed this pool. It was where fluids were coming out from the subsurface. We saw a little gas escaping from these features yesterday, but there's a salt. That's salt encrusting this, and the brine is gone, but it's relatively recent because that would eventually redissolve in seawater, all that white crust. Yeah, this is a pretty big. It's a pretty big feature. Another recharge area on the left. It's another one of those. That's how the pool would have been regenerated with bubbling, supersaturated fluids from below. Exactly. No, it looks like an old salt pan. I mean, if you fly over playa lakes in Utah and Nevada, you believe me, this looks very similar. Those are salt. Those are salt deposits. You know, and when the brine pool was full and it was overflowing into those channels, and then slowly decayed and died out, then that's what's left. Those salt deposits. Another recharge area on the left below that fish. Is it?
No, that's a halosaur.
Again, facing
Did
up
you
current, I'd wager that the current is from right to left here.
did you get a good enough shot of a halosaur earlier video? Okay.
But that's a halosaur that wants to be in the picture.
Oh wait. Oh, no, never mind. Mike, did you say this was a cutthroat? I would have been wrong about that. Sorry.
Yeah, and see, you know, and you can see that the relief is higher to the right. That was the shoreline on the left, and very, very smooth. That's because it's a flat-floored depression. And you could be looking down on interior drainages in the state of Nevada or Utah or Arizona now from 10,000 feet, but you're actually looking at the seafloor from about 2 meters. If we
Yeah, you had a good eye there, video. I was scrolled back behind on my messages.
if we see it, we can. They got a couple of candidates here.
Yeah, it's an interesting feature there.
Yeah, more brine pool on the left.
Brian in there, I think.
Is that the one we want? That one.
Yeah, let's swim away.
That now that
Can't
could be
see.
a little brine there, right in front of us.
I believe it is.
That could be a little brine right there.
Yeah.
Yeah, I think we've got, and you can see that brine is in the process of reequilibrating with seawater, and that's that fog you see above the surface. There's probably a little recharge zone somewhere beneath it, and you're getting a little bit of a pool remaining. It's great. What a great shot. Let's get our lasers on again, gentlemen. We'll get a feeling for that here. That looks like about it's a meter across, no, half a meter to a meter. Yeah, you can see it's just that's the reequilibration process of the supersaturated brine with seawater. You're actually getting a mixing going on, and as the mixing happens, you're getting salt precipitating. Looks like smoke, but it's actually it's the chemistry of the supersaturated brine with seawater intermixing. And call the ball. Very nice work, gentlemen. That was a good way to end the dive. You can see the shimmering in the water. You can just see it shimmering there. Again, that's the mixing of the brine with the seawater of normal salinity. And eventually that brine will go away. Unless it's recharged from below, it'll disappear. By the way, before I get off here, we're coming off the seafloor. For those of you who would like to participate in our post-cruise or post-dive conversation, we're going to have a telcon at 4 p.m. Central Daylight Time. That's about 1 hour from now. So we look forward to talking with you then. This is the Okeanos Explorer.
It's a giant isopod in front of us on the seafloor right now. These things are pretty cool, actually. Yep, that's it. They're scavengers on the seafloor. They're huge. They're kind of a crustacean. They can swim around. They're one of the weirder deep sea creatures. They have really weird eyes. It's hard to see them from here because they're on the bottom, but they're kind of like shiny and silver. I've seen little baby ones of these too. They're kind of cute. Look like an armadillo. Yes, do something cool. There's a little. Yeah, he has these really like pointy feet to. They do make burrows for sure, and they also are scavengers, so they have these pointy feet that they can just grab stuff and pull it off. Really strong jaws. Yeah, he's using the bury your head in the sand strategy, ostrich defense strategy. Yes, that's so cool. No. Nope. Not on this whole leg of the cruise. Yeah, I've never seen one behaving in this way either. Seen them swimming around, although I guess we've never really stopped and looked at them long enough.